Hello everybody. I am Dr. L. Vidya from Hindustan College of Engineering and Technology. Today we are going to see about this flame photometry. Flame photometry, basic concepts, instrumentation and application. The table of contents include using the flame photometer, introduction, energy state, principle, instrumentation, sample introduction, burners and flame, mirrors, monochromators, detectors, applications and limitations. Using the flame photometer. Spectroscopy is a study of light produced by a substance. It is a common form of chemical analysis based on the principle of Bohr's model. Atoms absorb and release specific wavelengths of light. Flame photometry or flame atomic emission spectroscopy. It is a type of emission spectroscopy where atomic emission is measured using a spectrophotometer. So when a metallic species is introduced in the flame, it burns and emits certain colored wavelength, and the instrument is based on the measurement of intensity of the color. Each metal will give a characteristic color, and the intensity of the color depicts the amount of quality of metal present. History. In the year 1800, scientists such as Kirchhoff, Bunsen burner, Angston, Rowland, Michelson, and Balmer studied the composition of the sun based on their emissions at different wavelengths. In February 23, 1955, Murray Nelson filed a patent for invention of flame photometry, which was granted in the year 1958. The energy of state. Accordingly, all the atoms in the specific lowest energy state, when it gets excited in the ground state, it moves to the next level of state, and there gets excited, and again it moves to the ground state. The principle of the flame photometry. Liquid sample containing metal salt solution is introduced into a flame. Solvent is vaporized, leaving the particles of solid salt. The salt is then vaporized into a gaseous state. All the gaseous molecules will dissociate to give neutral atoms. These unstable atoms, excited atoms, will emit photons while returning to their lower energy state. The measurement of emitted photons forms the basis of flame photometry using photomultiplier tube detectors. Instrumentation. It has the components of various systems like sample delivery system, burner and flame or source, monochromator, detector and recorder. Instrumentation. Diagrammatic representation. Components. Some basic steps. Liquid sample, that is the metallic salt solution, and formation of droplets, fine residues, formation of metal atoms, the excitation of the atoms by thermal energy, emission of with the specific wavelength, and measurement of emitted radiation. The flame of atoms of sodium is bright yellow in color, potassium followed by potassium, then lithium in crimson red color. So these are the different atoms which emits colors. Barium gives in lime green color, sodium gives yellow color, bright yellow color, then followed by that calcium is in orange color, lithium is red in color, and potassium is violet in color. Sample introduction. There are three components for introducing liquid sample: nebulizer, aerosol modifier, and flame or atomizer. Nebulizer, it breaks up the liquid into small droplets, and in a modifier it removes large droplets from the stream and allows only small droplets. For that it can easily as to pass. Atomization converts the analyte to free atoms. Nebulizers. Types of nebulizers. There are three types of nebulizers: pneumatic nebulizers, electrothermal vaporizers, and ultrasound nebulizers. Electrothermal vaporizer contains an evaporator in a closed chamber through which an inert gas will carry the vaporizer sample into the atomizer. Ultrasonic nebulizer, the sample is pumped into the surface, and then followed by that the resulting mist is denser and more homogeneous than that is in pneumatic nebulizers. Burners. There are different types of burners used. They are Mecker burner, total consumption burner, prefix burner, nitrous oxide acetylene flame. Burners. Nitrous oxide acetylene flame. This is the flame where you have the superior to the color flames for effectively powdering the free atoms. Structure of the flame. We can see the different zones: primary zone, preference zone, internal zone, and secondary reaction zone. These are the list of fuels and the oxidants used in that flame photometer. Mirrors. The radiation is emitted by the flame is generally towards all the directions. Hence, a mirror is placed behind the flame in order to force the radiation towards the external grid of the monochromator. A concave mirror is used to trap the, and it is used for reflecting type. Monochromators. There are two types of monochromators. They are prism monochromator and grating monochromator. Detectors. The next part is the detector, photomultiplier tube, photoemissive cell, and photovoltaic cell. Applications. They are the flame photometry finds in qualitative analysis, quantitative analysis, and also it is estimated to find other elements like sodium, calcium, potassium. Limitation. As the temperature is not high enough to excite transition metals, therefore this method is selective only for the detection of alkali and alkaline earth metals. The relatively low energy is available from the flame leads to relatively low intensity of the radiation from the metal atoms. The lower temperature will render to interference and the stability of the flame and aspiration conditions. Interference by other elements is not very easy to be eliminated. Thank you.